So let's get started. We are going to talk about exponential functions. For instance, you've been dealing with exponents for years. A function that has an exponent is a function like this. F of x equals x to the third power, for instance, or x to the second power, or there's an exponent. But exponential functions look like this. The base here is x. I remember that the base is the base because it pushes up the exponent like you would expect a base to do. Here the basis is a variable and the exponent is a number. But with exponential functions, the base is a number and the exponent is a variable. So that's what makes exponential functions exciting and different. So we're going to start off by looking at the graphs of different exponential functions. For instance, notice that these 1, 2, 3, 4 functions all look alike, basically. They have minor differences, but they all cross the y-axis at 0, 1, okay? And they all come down closer and closer and closer to the x-axis, but they never actually touch the x-axis, so that the x-axis is the horizontal asymptote. I have all of this written down later. Anyway, the base, which is the big number that holds up the exponent, the base is greater than 1 on all of these, greater than positive 1, so you have a graph that looks like this. It rises constantly. It rises for its whole domain. It's a constantly increasing function. Now, if your base is a fraction, like 1/2 or 1/3, it decreases from left to right. It's a constantly decreasing function. So when the base is a fraction, between 0 and 1, you have a graph that looks like this. But when the base is a number greater than 1, you get a graph that looks like this. Okay, so let's talk. Here's your base, here's your exponent, and the x-axis is the horizontal asymptote. Okay, whether your base is a number greater than 1 or your base is a fraction between 0 and 1, the x-axis will always be the horizontal asymptote. Now, graphing these is easier if we look at transformations. So back on October 5th, we talked about transformations of functions. And we are now going to talk about them again, but apply that to exponential functions and logarithmic functions, which we have not gotten to. We haven't gotten to the logs yet, we will. But right now, remember that this is your basic function part. So we could just call this f of x if we wanted to. If there's a negative sign out in front, then the function is reflecting across the x-axis, which means it goes upside down. And a number in front of the function part is a vertical stretch or a shrink. And a number added or subtracted from the function part at the end here is the vertical, or it's the vertical shift, one way or the other. It's either a vertical shift up or a vertical shift down. So here we're looking at a reflection across the x-axis. We're looking at a vertical stretch or a vertical shrink, and we'll talk about those. We're looking at the function part. So the vertical stretch or shrink multiplies the function part. And then to move this graph or any graph up or down, you're going to have a number added or subtracted from the function part at the end. Now over here, we're concentrating on the horizontal movement. Okay. The horizontal movement occurs where the x is. So a negative sign in front of the x means that the graph is going to be reflected to the other side of the y-axis. A number in front of the x is the horizontal stretch or shrink. A number added or subtracted to the x is a horizontal shift either to the left or to the right. So yes, we are going into transformations hot and heavy as they relate to exponential functions. And you're going to meet E, which is a universal constant like pi. So let's get to work. Here we have f of x equals 2 to the x minus 5. Well, you need to be able to figure out what the basic function is. Remember, that's always a part of working with transformations. What is your basic function? Well, the basic function is y equals 2 to the x. And here it's being changed to f of x equals 2 to the x minus 5. We can even put that in parentheses if we want. This is a horizontal shift, and if you remember about horizontal shifts, they are tricky. Yes, you're going to move 5 units either to the left or right, but which is it? It's always going to be the opposite of the sign in front of it, not what you would expect. The best way to figure out what direction your horizontal shift is going to go in is to take, well here, x minus 5, set it equal to 0, and solve for x. You'll add 5 to both sides, which means x equals positive 5. So the horizontal shift is going to be 5 units to the right. So we have the graph 2 to the x up here. If you can imagine this being physically moved over 2 units to the right, not raised up, not raised down, not put down, not flipped in any way, only physically moved 2 units to the right. Now, f of x equals e to the 3x. Well, This is different. E is, well, first let's look at pi, universal constants. You know two of them, there are more. There's pi, and that's a number that's about 3.14. There. It's about. It's not exactly equal to. Well, E is a number that's about 2.7. Really close to 3. But we don't write 2.7, we write E. So this is E to the to the 3x power, and what we have here, we have over here y equals e to the x. This is the graph of y equals e to the x. So how is y to the 3x going to change this? And the answer is that just about everything, maybe everything, involving horizontal movement is backwards. Backwards is like inverted from what it is for the y's. For instance, let me find another page here and remind you that if you had f of x or y equals, well, how about 3 times e to the x? Then because this is a number greater than 1, 3 is greater than 1. So you know that this is a vertical stretch. On the other hand, if you've got f of x, or maybe, I know technically we should be calling it g of x. What if we have 1/3 times e to the x? Well, this 1/3 is a vertical shrink. A vertical stretch pulls the graph up vertically. A vertical shrink squishes the basic graph vertically. Squish. Now, what we're dealing with in this problem is f of x equals e to the 3x. And while I'm at it, I'm going to write over here, let's call it g of x. I'm feeling guilty for calling these things by the same letter. Like I've committed a crime or something. There. Remember that everything near the x, and there's a name for that we're going to talk about later, but right now I want to look at this. I would expect that this would be like f of x up here, that this would be a horizontal stretch, and that would make perfect sense, but it's not. That 3 is a number bigger than 1, and because we're dealing with horizontal stuff, This is actually a horizontal shrink. Here's what happens. Up here, this number, whether it's a big number or a small number, that multiplies the y coordinates of all the points. So does this. It multiplies the y coordinates. But I'm sure it's not news to you that if you multiply a number by a number greater than 1, that the number you multiply is going to get bigger. And if you multiply a number by a fraction, a number between 0 and 1, that the number you multiply gets smaller. In fact, it'll only be 1/3 as big. Well, down here in the x's, in what we call the argument of the function, wherever the x is the argument of the function. Down here in the argument of the function, what happens is this number, whatever it is, divides the x coordinates. So this number divides the, I'm going to write it down below because that's just too small. The 3, let's see, how can I say this? All of the x coordinates of all the points are going to be divided by 3. 3 divides all the x coordinates. Okay, so suppose x equals 6. If 6 divides 3, you'll have 6 over 3, which is 2. When 3 gets done dealing with the 6, the x coordinate is smaller. Now it's a 2. It was a 6, now it's a 2. This is something you have to memorize. Now, if you come over here, suppose x equals 6. This number is going to divide the 6. You'll have 6 divided by 1/3, which is 6 divided by 1/3. But when you divide by a fraction, you invert and multiply. So this is going to be 6 times 3, which is going to be 18, which is a whole lot bigger. So if the number in front is a fraction, like 1/3, between 1 and 0, then what you're dealing with is a horizontal stretch. Like an accordion, a stretch pulls it out, a shrink pushes it in. So you're going like this. 3 pushes it in, 1/3 pulls it out. This is a horizontal stretch. That's one of the most difficult things in math to remember. But you have to. So get out those flashcards. Okay, now. Where were we? Ah, here we are. So here, now notice that the 2 is being raised to the x. Actually, it's x minus 3, but this part tells you what the basic graph is. And this part tells you what the basic graph is. And e to the x tells you what the basic graph is. So these are actually problems in your homework. Here we are back to this stuff. So anyway, e to the 3x is going to be horizontally shrunk by a factor of 3. Now over here, the basic function, is 5 to the x. Five to the x is being shifted horizontally to the left by 4. And the very safest thing for you to do is to say x plus 4 equals 0 and solve that so that you can actually see x equals negative 4. Negative means left when we're talking about horizontal. Okay, so set this equal to 0, and you will see that you're going to take the basic function y equals 5x. I should have said y equals 5x. Five to the x, I'm sorry. It's going to be shifted over to the left 4 units and then down 3. This is the vertical shift down. So horizontal shift of 4 units to the left and a vertical shift of 3 units down. This is the vertical shift out here on the far right. This is the horizontal shift up here with the x. Now, out here, your basic function. Is y equals 2 to the x power, and we have that already graphed up here. Although, quite honestly, y equals 5 to the x would look pretty close, because they all look basically alike, with a few points different. Well, there are points different, but the shape is the same. All right, now, the 5 in front is a vertical stretch. The minus 3 with the x, take x minus 3, set it equal to 0, add 3 to both sides, and you will get x equals positive 3. So this is a horizontal shift to the right 3 units. Even though it doesn't look like it's supposed to be, it is. The plus 4 on the end is a vertical shift up 4 units. And finally, the basic function is y equals e to the x, which is shifted up here. Which is graphed up here. So the basic function. Y equals e to the x. Now, that negative sign in front of the x is a reflection across the y-axis. I wrote it down here, but let me put an arrow going to this negative sign right there. A reflection across the y-axis. And then, shifting to the left, 3. Now the professor will. I'm actually going to graph these things for you. Graph. But before I go to that, I want to make sure I talk about this. Here's your new world. If you've never had college algebra or algebra 2 in high school, then you have never heard of a logarithm. But if you're in medicine, it's really important. Okay, so a lot of nurses in our class, people who are going into nursing, the pH scale, your blood pH between basic and acidic blood has to be in a certain balance, and that is given by a logarithm. You'll discover this Monday. But right now, we're going to talk about what the heck a logarithm is. The logarithm function is the inverse function of the exponential function. And here they are. If f of x equals 2 to the x, then the inverse function is going to be log base 2 of x. See, the base is the same. The base is here for an exponential function. It's down here as a subscript for the logarithm function. Over here, if our function is f of x equals 3 to the x, then the inverse function is going to be log base 3 of x. You're going to learn a whole lot about these. Today, we're just going to learn the very, very basics. If f of x equals 10 to the x, then the inverse of that will be just log x, because the 10 is understood. If you don't see a base down there, then log x means log base 10 of x. It's on your calculator. And if f of x equals e to the x, then the inverse function is written ln of x. But what ln of x is log base e of x. But we don't write this. We write it like this. This is called the natural logarithm. Let's just say log. Logarithm is such a long word. Whereas these, especially this, excuse me, is called the common logarithm, because we live in a base 10 system. There's no reason to keep writing 10 over and over and over and over again. So it's called the common logarithm. Okay. Now here's what they look like. Here's the graph of y equals 3 to the x power. The horizontal asymptote is the x-axis, and this rises until it crosses the y-axis at, it rises slowly until it crosses the y-axis at 0, 1. And then it starts rising really, really quickly. So quickly that it's really difficult, if not impossible, to use exponential functions for measuring. So for that reason, we switch to the inverse, the logarithm function, because it rises very, very slowly. So it's easier to measure quickly rising amounts with a logarithm. So this is the graph of f of x equals 3 to the x, and this is a graph of f inverse of x equals log base 3 of x. They kind of face each other. Notice that the exponential function crosses the y-axis at 0, 1, and the logarithmic function crosses the x-axis at 1, 0. They trade domains and ranges because they're inverses. The domain of the exponential function is negative infinity to positive infinity. Well, the range of this logarithmic function is negative infinity, way down here, to slowly rising up to positive infinity. So check these out and you'll see that the domains and range trade because they're inverses. And these are some important facts about each one. We're going to get into this much more on Monday. Starting on Monday, we'll be working with logarithms and exponents for the rest of the semester. So you will become very, 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 very familiar with them. Okay. But for now, the rules of transformations are going to stay completely the same. Here you have f of x equals log base 2 of parentheses x plus 2. This is the argument of the function. Okay. The plus 2 in here with the x is going to be horizontal movement. So you take the x plus 2 out and you set it equal to 0. Subtract 2 from both sides. You'll have x equals negative 2. Horizontal movement, the negative here, means go to the left. So after you set this equal to 0 and solve, you will see that this takes the basic graph of log base 2 of x and moves it to the left 2 units. Log base 2 of x is going to look basically like log base 3 of x does here. So imagine this being moved to the left 2 units. So it'll go boom, boom. It'll be back here. Back here. Now log base 3 of x plus 2. Well, this is a basic graph, log base 3 of x, and it is being shifted. Now this plus 2 is outside the parentheses. So plus 2 is a vertical shift up 2 units. Follows the same rules. Here's a number in front of the function. Our basic function is log x, which means log base 10x. Basic is y equals log x, with the base 10 understood. All right, this number in front of the function is going to be the vertical shrink. This number out here, let's go to this one first. This is the vertical shift down. The Y movements are always easy to look at because they're obvious if you start to think about them. A minus sign should take a graph down. It should be a vertical shift down. A function a fraction multiplying the function should make it shorter. But it's just the opposite in here. In here, this is a horizontal shift 5 units to the right. So this is all reading the math code. Now, let's go actually do some problems on my math lab. Let me save. Then I'll minimize this, and I'll minimize this, and I'll minimize that. And I will call this up. So let me make this bigger. Okay, notice you have a video here to tell you how to do this, but let's just walk through this. Here you have 2 to the x plus 2. So your basic function is 2 to the x. Now, what you're being asked to do is start with the graph of y equals what? 2 to the x. Then, are we going to shift it to the left? Yeah, we are, because a plus sign up here with the x means go to the left. So I would click on A, except of course I haven't put my 2 in yet. Let me do that. All right, start with the graph of y equals 2 to the x and shift the graph 2 units left. Absolutely. Check my answer. Okay. Now we're going to graph it. You don't really need points to graph, as you will see. So if you're not good at graphing, you can take a sigh of relief. Here's what we do one step at a time. If you read the yellow banner, it will help. Let's see if I can make this bigger. I don't know if I can. Yeah, a little bit. Except I can't get to save now, doggone it. Well, for the moment, the first thing I have to do is choose the tool in the palette. Well, exponential functions, and this is an exponential function. Exponential functions, their icon looks like this. So I'm going to click here. Then it doesn't matter where I click here, so I usually click at the center. This is the basic graph y to the 2x. Actually, it's not. It's the basic graph y to the ex. We're going to have to change that. Let's change it right now. Oh, are they going to make us go in order? No. Base is 2. If you recall, this is f of x equals 2 to the x plus 2. Okay, so I changed the base to 2. Now, there is no vertical shrink. There is no horizontal shrink. There is no vertical shift, but there is a horizontal shift of 2 to the left. And when you solve for x, you see, that's why I really can't make this smaller. I mean, yeah, bigger. Okay, when you solve for x, when you take x plus 2, set it equal to 0, solve for x, you get x equals negative 2, which you now have right here. We have shifted the graph horizontally 2 units to the left, changed the base to 2, and those are the only changes we need to make. So, I now have to make this smaller. And I'm going to save. Check answer. Ah, good. Okay, now here was our function. I don't want to move to the next problem yet. 2 to the x plus 2. So the basic function again is 2 to the x. And what we did was we shifted 2 to the left. When you take x plus 2, set it equal to 0. You have to subtract 2 from both sides, so you'll get x equals negative 2. That's what shows you the direction you're going to go in. Okay, let's go to the next problem. Now here we have e to the 2x. It says, describe how the graph of the function can be obtained from the graph of a basic exponential function. You might feel a little bit afraid of e right now. In fact, I'm going to do this. This will help. This will make it bigger. There. No, that won't. Oh well. This is going to be e to the 2x. Now what a 2 in front of the x means, 2 is a number bigger than 1. A number bigger than 1 multiplying the x coordinates is going, not multiplying the x coordinates, dividing the x coordinates is going to make the x coordinates smaller. So this is going to be a horizontal shrink. And our base is e. So let's come down here. Start with the graph of y equals e to the x. Since the constant factor in the exponent is 2, the graph should be shrunk. Horizontally, because the 2 is up there with the x. Now I check my answer. Excellent! I love it when it says that. Okay, now I have to click that. Now the reason I wanted to take a picture of it is so I won't forget that the 2 is up there in front of the x. All right, so this is an exponential function. A number with an x in the exponent. So I'm going to choose the icon, the avatar, for an exponential function. And then I'm going to click anywhere. Now the base is e here. So this is the graph of the basic function y equals x. Ah, but now use the given interactions to edit the selected function. Oh, there it is over here. Okay, this is another dealie you can have. we are going to have a horizontal shrink. So right here we put the factor. And now I'm going to say 2, but it might be wrong because really we're going to be shrinking by a factor of 1/2. So let's see, I'm going to say 2 and we'll see if it gives me credit for it. I don't think it will. It did. Okay. Fine. Now here we have 2 transformations. We have a horizontal shift to the left, and we have a vertical shift down. And the basic function is 2 to the x. So start with the graph of y equals 2 to the x. Now, I want to take a picture of this just so I can have it. There, all right. Now shift it 5 units. Okay, now we're 5 units. The 5 is here. I have to decide which direction to go in. Well, I know that if I set x plus 5, x plus 5 equal to 0, writing with a mouse is terrible. Let's see if I can write with my stylus. If I subtract, can't go away. If I subtract 5 from both sides, I will have, it's George, of course. George is the #1 troublemaker around here, except for me. X equals -5. Okay, so now I know what direction X is going in. It's going left. This is a horizontal shift to the left, 5 units. So all I have to do is find the word left. And there it is, left. And then I'm going to shift, that's a -2 on the end, so it's going to be down 2 units. Now I check my answer. Good. Now I graph the answer. Again, it's an exponential function. I click on the symbol for an exponential function and then I graph that. Now, this is saying again, because this is the default sometimes, but not always, that the base is e, it's not e. So just go ahead and get rid of the e and put a 2. Now, I am going, and notice that when you do this, you've already decided you don't even really need to have the graph up there if it will cooperate. Of course it won't, but at least I can temporarily drag it. I'm going left 5 and down 2. So, vertical shift. Oh, no, there's a vertical shift. There is no vertical stretch or shrink. There is no horizontal stretch or shrink. There is a vertical shift down 2 units. So that will be down is -2 or -2. The horizontal shift is negative. That was supposed to be an arrow, but it was kind of a sickly arrow. Okay, yeah, the horizontal shift is going to be -5. Did I mess myself over? Really? I did. Beware. Dog. Oh, well, I already had it in. Let's see if it's right. If not, I'll just do it over. Yeah, all right, you piddle poop. Okay, going back. Gonna clear. Yes. One more time. Click that. Click that. I'm going to have a vertical shift down. -2. See, you can see what number it is, so you can double check yourself. And then I'm going 5 to the left, that's a horizontal shift. 5 to the left is a -5. And then I'm changing my base to 2 because the base is 2. And then I'm going to save. And then I'm going to check. Ha! All right. This one is hard. I wanted to be sure that I did this one for you. That is going to be a vertical stretch. -1 up by the x -1 is going to be a horizontal shift 1 unit to the right. And the +3 at the end is going to be a vertical shift up 3 units. They're not asking me to fill in anything. They're asking me to just graph it. But I'm graphing it with knowledge, not with points. One can be as scary as the other. Okay, click. Exponential function. Click anywhere. What do you know? It says this time the base is 2. So right now this is the graph of the basic function y equals x to, 2 to the x, not x to the 2, 2 to the x. Now I'm going to start filling in the information. The 3 multiplying 2 to the x -1, that 3 is a vertical stretch. So I come over to vertical stretch shrink and I go to +3. Then there is no horizontal shrink, or I'd have a number bigger than 1 in front of the x. There is no horizontal stretch, or I'd have a number smaller than 1 rather, in front of the x. I've only got a 1 in front of the x, and that is the default number. Meaning, nope, there's no horizontal stretch or shrink. Yay. However, there is a vertical shift up 3 units, that's positive. And there is a horizontal shift 1 to the right. That's +1. Now I'm going to save, and I'm going to check. Yay! And now it's going to ask me things. Describe how the graph can be obtained from the graph of the basic exponential function 2 to the x. Choose the correct answer below. I hate it when they're combinations. All right. A, shift the graph of y equals 2 to the x left 1 unit. No, I'm going to throw that out. Shift the graph of y equals 2 to the x right 1 unit. Well, that could be it. Stretch it vertically and shift it up 3. That is definitely it. See, the other one, C says down. We're not going down, we're going up. So B is my answer, and I check my answer. Good. All right, finally, because you only have 7 problems here. E to the -x minus 3. All right. E is your base. The basic function is e to the x. Oh, I do want to have a copy of it though. E to the x. Okay, now, this has always perturbed me. Let me analyze this for you first. The negative sign in front of the x means you're going to reflect across the y-axis. It's a sideways or horizontal reflection. Then you're going to move the graph 3 units to the right. So, let us begin. Shift the graph of y equals e. I have an e on my keyboard. E to the x. Now, sometimes it's a problem trying to figure out what they're asking. So, units, and then, all right, let's look at our choices. Down, I'm not going down. Left, right, okay, I'm gonna go right. 3 units. And then reflect it across the y-axis. Let's see. Woo! Now we're going to graph it. And I need all this information. Remember that you have only 2 transformations. Unfortunately, they're both in the argument of the function where everything is kind of sort of backwards. Unless you go to more steps. Okay, so click exponential function. Click anywhere on the grid. Now, e is the base, so this is the basic function of y equals e to the x. Now, I am going to have, what should I do first? I'm going to get rid of the reflection. I'm going to have a reflection across the y-axis, so I come over here, and these 2 boxes down there are for saying, yes, you'll have a reflection across the x-axis, but I don't. I have a reflection across the y-axis, so I click here. That's taken care of. Now, I have a horizontal shift, 3 units to the right. Horizontal shift. 3, no, that's a shrink, you silly person. Put a 1 back there. Horizontal shift. 3 units to the right. Let's see if this is right. Note the given function is an exponential function. Perform the transformations found in the previous step. Thought I did. Let's do it again. All right. Exponential. Click. The base is E. I am going to shift to the right 3 units. And then I'm going to reflect across the y-axis. But it went left. So I am going to just put a 3. Now, okay, here's our secret weapon. Here's E, by the way. However, there's a quicker way to put E to a power. You'll learn about this on Monday too. Second ln. That gives you E and a little box. Because they're inverses, and that's just the way your calculator is built. That's the way it is. So negative x minus 3. We're going to graph this. Aha. Aha. So, this is my last time. The pressure is on. Here, here. Here. Oh, delete. Oh, there. Not going to put a negative in front of it. I am going to put a negative in front of it. However, I think you've got two different people programming this. That's not the way our graph looked, is it? Wait a minute. There, that's the way our graph looked. Well, save. Just remember to look at this. Okay, I'm going to tell you why. There's often an argument here. Where's this? We've got to get to logs. But anyway, here's what happened. We had e to the negative x minus 3. This is what I should have done. Negative x plus 3. If I distribute this negative, that's how I get my negative x minus 3. Okay, so if I do that, then it will be the x plus 3 I set equal to 0, which means I will have x equals negative 3, which, is that what I wrote? Okay, yes it is. It's what I wrote, and now I understand what they're doing. That's always the hardest part. So now we understand together. Cool. Let's graph a log. Save. Heck no. Okay. Let's go to graphing logarithmic functions. It's the same idea, exactly. Oh, you only have 3 questions here. Well, that's letting you off easy. All right, here we have f of x equals, and this is what you say here, log base 3 of x minus 1. The argument is x minus 1. Okay, now I can even do this. And see how much bigger that is? Yeah, we're going to keep that guy around. Log base 3 of x minus 1, where this is the argument. the arg. All right, this is the argument, therefore the x minus 1 should be set equal to 0, plus 1, plus 1. Negative 1 plus 1 is 0, so we'll have x equals 1. We're going to the right. All right, 1 to the right, that's it. So the graph of f of x equals log base 3 of x minus 1 could be obtained by translating the graph of y equals log base 3 of x 1 unit to the right. Check answer. Yeah. Now we graph it. You don't have to know how to graph a logarithm function, except to know the general shape is this. And click anywhere. This is, they kept the base. The base is 3. This is the general graph of y equals log base 3 of x, the basic function, which is here. Pulling it down, y equals log base 3 of x. That's the basic function. And now we're going to move this horizontally 1 unit to the right. Horizontal shift. 1, positive 1. Save. Check. Cool. All you had to know for this was that x minus 1, I mean, anything in parentheses with the x is going to be part of the argument, period, no matter how weird it looks. Now, use the graphing tool. We did that. What is the domain? Now, this is interesting. The domain of the basic graph, well, here, the domain of the basic graph, I just happened to graph that. The domain of the basic graph of log base 3 of x is, this is an asymptote. It's never going to cross x equals 0, which is the equation of the y-axis. So the domain is paren 0, comma, infinity, because it goes to the right forever, but it never crosses the y-axis. Now, if we are shoving this to the right 1 unit, this will become the asymptote. And this will be where the graph crosses. So, the asymptote would have been x equals 0, but now it's x equals 1. So exciting, I'm getting the hiccups. No, yeah. What is the domain? Yeah, okay. Duh. Okay, paren. 0, comma, infinity. Close paren. There you go. I was getting careless. Yes, x equals 1 is the equation of the new vertical asymptote, but that's not what they were asking, and this has to be a 1. There you go. Now, 1 to infinity, not including 1 because it's an asymptote. There you go. Okay. I have not completed? Am I sure I want to leave? No. Well, what have I not done? Now it's saying the vertical asymptote is x equals, yeah, you... Boy, do I want to call it a name. Okay. There we go. Now we're going on to 2, where again, log base 3 of x is your basic function, but now all you're going to do is, you know, it doesn't matter what that looks like. The plus 2 on the end means it's a vertical shift up. So you're going to shift the graph of y equals, now, up, 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 down there on D. Now watch this. This is how you do this. Log, L-O-G, you type it out. Now, the base is written as a subscript, so you click the subscript tool, click, put a 3. Now you have to hit your right arrow key to come back up. And now parentheses, x parentheses. Shift the graph of y equals log base 3 of x up 2 units. Oh, and we have to graph it. All right, all right. Well, now this is the graph of the, well, and it says logarithm tool if you hover your mouse over it. And then click anywhere. So it's already provided you with your base. All you have to do is say, okay, I've got a vertical shift up 2, so that will be positive 2. And there's that. One more. Important. I didn't complete it. Good grief. Oh, I didn't check the answer. Okay, all right, all right. What is the domain of the function? Well, here we didn't shift sideways, so the domain is still 0 to infinity. With a parenthesis. 0, comma, infinity, parenthesis. Now, what is the equation of the vertical asymptote? X equals 0, because x does equal 0 all along the y-axis, and the y-axis is your vertical asymptote. So x equals, notice they didn't put the x equals there for you, so you have to do it. X equals 0. Now are you going to let me out? All right, now. This is the function part. Notice there's no base, so there is a base, it's 10. This is the common logarithm. Now, 1 divided by 2, that's 1/2, and that's in front, that's out in front of the function, so it has to be a vertical shrink. All right, so let's answer these questions. Describe how the graph of f of x can be obtained from the graph of the basic logarithm function. Shift the graph of y equals log x, so they're giving it to you. 2 units to the right. That's the horizontal shift. Shrink it vertically, horizontal shrink, and then shift it 3 units down. Down 3 units. Now we graph it. One more time. The logarithm tool, click the graph. They've given you your base. They didn't leave it up to you, not yet. You're going to have a vertical shrink of 1/2. Oh dear. Oh. There we go. 1/2. Kind of freaked for a minute. Yeah, 1/2. Okay. Now we're going to have a horizontal shift and a vertical shift. A vertical shift of 3 down, so that's -3. And a horizontal shift of +2, which means 2 to the right. And then we'll save. And we'll check. Ha! The domain is, look at this, we shifted, the domain would have been from 0 to infinity, but we moved it over 2 to the right, so now x equals 2 is going to be the vertical asymptote. So the domain is going to be 2 to infinity. I always have trouble with that. I need to just stop trying. No, stop it. Check answer. Yeah. Now look, the vertical asymptote is they have x equals, so you just put in the number. 2. Okay. There you go. Everything you need to know to graph exponential and logarithmic functions, because you don't need to know any of the intricacies. They do transformations just like any function does. So just follow the transformation rules. And have a great weekend and hang around if you have questions, but we have gone a few minutes over. Oh well, see you Monday and we will delve more deeply into the world of logarithms and exponents, that is exponential functions and logarithmic functions. See you later.